Okay, pyramids. A pyramid is a square bottom with 4 triangular faces. So for those of you that are in class, you can see me holding this up right now. It's basically like this. And what happens is all 4 sides fold up. They meet in the centre of the square. Yeah? So if I was trying to draw a fancy diagram of this, it's always good to start off with to make this 3D. All you need to do is get yourself a parallelogram. Try and make it a reasonably square looking parallelogram. And then what you do next is you just go upwards to a common point. And lo and behold, you now have a rough pyramid, right? So, not a great one, but sure, look, I think I made it too rectangularly. So, go one more time. That a bit more of a square looking, is it?
Left a bit.
Left a bit. Alright, let's try this out again. One more time. One. Yeah. Not great. Now. Alright. That's all.
It's got a face. It's too squarey now.
Yeah, it seems to be, doesn't it? Now. Alright, you're just going to live with it. Now. What we're doing next is calculate the length of one of the slanted edges correct to the nearest metre. So, what does it mean by a slanted edge? Has a square base and 4 triangular faces. The base of the pyramid is 230 each way. So that's a 230, that's a 230, and that's a 230. Everybody alright with that? Yeah? 230 no matter what? And the pyramid is 146 metres high. Now basically what happens is, remember I discussed earlier that all 4 points, yeah, they go dead centre of the, would you agree with that?
Yeah.
Dead centre of the square. Believe it. Dead centre, yeah? It's right underneath the peak.
Yeah.
Go with that?
Yeah.
Now, here's what I'm going to do. I'm going to draw, we're told that this here is 140. We're told that's 146, aren't we? Now, if I do something like this, and imagine that point down there, yeah? We drop a line straight down and we go straight across. What type of triangle is that? Right angle, isn't it? So here's what we're going to do. A right angle triangle. I'm going to drop it. I'm going to drop straight down from the peak to the bottom. Because that's vertical to horizontal ground, that's a 90-degree angle. Then I'm going to draw another line out to here. And I've got myself a right angle triangle. The right angle triangle, however, is of height 146. But I currently don't know either one of the other 2 sides. Everybody right with that? I then go back to my base. I go back to this guy here. Yeah? And what I'm going to try and find out is, I go back to my square base, and I'm going to try and find out the distance of here to here. Everybody right with that? Here's how I'm going to do this. 230 one way, 230 there, other way. I'm going to find this length here. How do I find that length there? Pythagoras. Half the distance, and I'll get here to here. Everybody right with that? So Pythagoras said 230 squared plus 230 squared, square root the answer. Yeah. 325.27. Yeah. $325.27. Half the answer. I'm going to do it to 3 decimal places because 635 is a dodgy one to round up or down, right? So 162.635. What can I do to find the slant edge now? Huh? Yeah, so what I'm finding out is this edge here, yeah? You all right with that? Straight down, straight across. Okay? So, I'm about to find out one of these slant edges right now. One of these guys here. Okay? So, Pythagoras' theorem one more time. X squared equals 146 squared plus 162.635 squared. Look, I'll just square that, won't I, with my ass answer, yeah? Square that. Add that to 146 squared. Root my answer. Same deal again, isn't it? 21855. 4. Okay. And how many? What does it want to nearest meter? 219. Now, what's it going to ask me for next? It wants calculate the correct two significant figures. Anybody know what significant figures are? Example. 45,163 is 5 significant figures. 45,000 is 2 significant figures. 50,000 would be 45,001 would be actually 5, because the zeros are sandwiched in between. Significant figures, right, guys? Okay. Now, let's get back to it. It wants me to calculate the what, guys? It wants me to calculate the four triangular faces. It wants me to get 1, 2, 3, and 4. Let's concentrate on the triangular faces. So with the triangular faces, okay, guys, we're talking about the 4 of them here, aren't we? These guys here. Now, for argument's sake, I don't need to draw them all. Pretty much I only need to draw one of them because they're all the same. What's the base? 230. What's the slanty edge? What's the other slanty edge? What type of triangle is this? Isosceles. Which means when I draw something down the centre, cuts it in half. So I effectively have 115 and 219, and I can use a half base by height because I can now find out the perpendicular height. That makes sense? So Pythagoras' theorem, this we'll use a different letter at this stage, yeah. So 219 squared equals. Then it's going to be 219 squared, take away 115 squared, square root the answer, 186.38. Now, what's the area of this triangle then? Half 230, 186 point. That's one triangle. There's 4 triangles. Multiply by 4 to get the 4 triangles. No, 4 triangles. That's the area of one triangle.
Oh, okay.
Multiply by 4, yeah? How many significant figures did you want again? 2. 86,000. You have to round it off to 2 significant figures.
So because you like half the isosceles triangles, that like it's half that's the area.
No. I used the isosceles triangle to get. I used the right angle triangle to get the height. And then the area of the triangle is a half base by height, so it's the full thing. Okay, and we are done with that one.
Videos.